welcome back. This is the second video for Chapter 8, Writing Classes. In this video, we're going to review some of the basics of object-oriented programming in terms of fields and methods and constructors and encapsulation. And then in the next video, we'll put those things into practice through a larger example. One of the key concepts to keep in mind is that in object-oriented programming, we're really focused on the data rather than on procedures. So, rather than designing programs as we have been, using hierarchies of methods, instead, what we're going to do is design programs that are collections of collaborating objects. And each one of those objects then will encapsulate its own data and provide some set of methods for working with that data. So rather than focusing on the methods and how they relate to each other, we're going to be focusing on the data and the objects that encapsulate them, and thinking about our programs as a collection of those objects that work together by calling each other's methods in order to solve a problem. Okay, so again, classes, which we're learning how to write in this chapter, allow us to group or encapsulate several different pieces of data that are all related to the same concept. For example, we can consider the 4-song playing MP3 player that we looked at in Chapter 4. So to start with, let's just take a look at that program in operation to remind ourselves what it does. Okay, so this is the 4-song MP3 player from Chapter 4. Just a quick review up at the top, we have variables for loading the audio, audio players for each of the songs, an alias, images for each song, a whole bunch of constants that tell us where everything is at. Setup, we load the songs, load the images, initialize our fonts. In Draw, we have to manage all those pieces of data individually. So we draw the images, then the labels. And in mouse-clicked, we have a very complicated if structure that determines whether or not one of those songs was chosen, and if so, sets the current song and then rewinds it and plays it. So in action, it looks like this. Where if we click on this image,
all right, this one's Mission Boy,
it plays a song. Now notice that in that program, for every song that the 4-song playing MP3 player can actually play, there are actually 5 different pieces of related data that all have to be managed separately by the program. So first and foremost, obviously, there's the song itself, the MP3 file that we're interested in playing. But in our program, there's more to it than just that. There's also an image that's going to be displayed on the user interface. And that image also has X and Y coordinates that need to be remembered. And also a caption for the image as well. So all 5 of those things then together really represent one song. So in an object-oriented paradigm, what we're going to do is create a class that encapsulates all that information into one unit. So this box represents a song class, and it will hold inside of it the song itself, but also the image, location, and caption for that song. And then we have a series of methods that we'll use to allow us to interact with that data as a whole rather than individually. And the benefit will be that this will help us to simplify our code, and we'll show you how much simplification we can achieve momentarily. Before we look at the actual code for this and compare it side by side with the Chapter 4 code, let's sort of imagine what a song class would have in it. So first of all, in this UML class diagram, in the middle box, we would have our 5 pieces of data that we talked about needing for every song. So we have the song itself, its image and caption, and then the X and Y location where that song is displayed on the interface. Down below, though, in the bottom box, we have a series of methods that this class supports, and that's the interface that we use in order to interact with this song object. So we have a method to draw the song on the user interface, which of course would display its image and its caption. We have a method to tell whether or not that song has been clicked on. We have a method to pause the song. We have a method to play the song. And we also have a method to close everything down. Now these 2 methods up here are constructors, and we'll come back to those in a minute. But right now let's look at a side-by-side comparison of the draw method of the MP3 player example from Chapter 4 compared to an MP3 player that might use these song objects instead. Okay, now let's compare these 2 versions side by side. On the left, what we have is the Chapter 4 version, and on the right we have one that's been objectified, turned into an object-oriented program. So on the left, in the draw method, we had to manage the images and the labels separately. But in this case, all we have to do is loop through an array of song objects and have each of them draw themselves. Much simpler than the draw in the previous version. Now if we look at mouse clicked, we'll find that's even better. So before we had to pause the song that was currently playing, use this big structure to determine who was clicked on, and then if one of them was clicked, play it. Now with the objects, look at that. We go through the array of songs, pause all of them. If one of them is clicked, then we play it. Again, much, much simpler. So that sort of illustrates some of the benefits of object-oriented programming and how much simpler it can make our code. Okay, now let's get some more terminology done before we move on to a larger example. In the UML diagram for our song class, we saw that there were some special methods there called constructors. We've used constructors before, obviously, when we've created p-image objects or when we've created minim objects. But we're going to revisit them now and talk about different kinds of constructors. First of all, it's important to remember that constructors are designed to initialize the fields of an object. Their purpose is to set values in those objects that make sense regarding or pertaining to how we're going to use the object. When we write classes, we'll find that constructors always have to have the same name as the class, and they never have return values, not even void. So in the next video, when we write constructors, we'll illustrate that in processing. Now there are 2 broad types of constructors. One is the default constructor, and that's what sets the fields of the object to sort of a plain setting. We also have initializing constructors, which allow us to initialize our object to individual needs. So think about it this way. A default constructor might be like what happens when you plug in an alarm clock for the first time, and it comes up with the flashing 12 o'clock. That's sort of the default setting. Whereas an initializing constructor somehow would let us plug in the clock and also set the time at the same time. Now if we return to our song UML class diagram, we'll see that we have 2 constructors listed. The first one is the default constructor. It takes no parameters. And the second constructor is initializing constructor, and so it takes the name of the file that holds the MP3 audio, the name of the file that holds its image, the X and the Y location where we're going to display the image, the caption that will go with it, and then the minim object that we're using to load audio files. And so when we create a song using this initializing constructor, we're able to pass in all the information that will make the object hold a specific song. There are a couple of other methods that we're interested in, other types of methods, and those would be accessors and mutators, otherwise called get and set methods. And what those do is allow us to safely change the values of the fields in the object. So to look at an example that we have in the textbook, suppose we have an alarm clock. Now inside that alarm clock there's a bunch of very complicated machinery or electronics that somehow remembers the time, has a radio, has alarms, has the ability to set for a snooze and all those types of things. And the question is, how do we access the guts of that alarm clock to set the time or set an alarm or turn on the radio? Well, do we want to reach in and poke the interior of the clock to try to make that happen? And the answer, of course, is no. What we want to do instead is access the interior of the clock through the buttons on the top of the clock, which represent the clock's interface. So in this situation, the buttons on the clock represent the set and get methods of an object, and they allow us to safely access the interior of that object without electrocuting ourselves. In other words, without doing anything stupid. For example, p-image objects that we've used have access and mutator methods that allow us to access and change pixel colors. And those, of course, are the set and get methods that we've used particularly in Chapter 5 if you did the image filtering examples. So to sum all this stuff up, when we design and write a class, there are several things that we should do. We should provide at least a default constructor, possibly one or more initializing constructors depending on how the objects are going to be used, and set and get methods as appropriate to manage access to the different fields and that the class encapsulates. So in the next video we're going to take all of these concepts and put them together, see how they work in processing code in the context of a larger example.